So what did we do? Listen up. What did we do yesterday? Come on. What did we do yesterday about quadratics? We learned that a quadratic must have only what highest power in it? Only the highest power of 2. Are you allowed to have any negative fraction or decimal powers? No. Are you allowed to have a power of 1 though? Are you allowed to have a power of 0, like just a single number next to it? Yes, but you cannot have any other negative decimal or fraction powers, okay? So that's the first thing. The second thing is, did we learn how to sketch them once you have the equation? Yes, by the way, I posted yesterday's lesson with the videos and everything, so you definitely make sure to actually go there and fill your notes if you haven't have them filled. So today we talk about some words that we need to understand when you talk about what? Quadratics. So let's talk about the first one. Who can pronounce the first word? Vertex. 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 So what is the vertex? It's but again, remember, we're not talking about lines anymore. We're talking about what? Everyone? We're talking about things that look like this or like this. Okay? Everyone, eyes on me. So the vertex is either the lowest point or, so it depends. If it's open up, it's the what? The lowest point. If it's open down, it's the what? The highest point. There you go. So the vertex is the highest or lowest. So highest, highest, or okay. So no problem. So it's highest if it's open down. Okay. So I want you to go like this. Either this point or this point. So it's either the highest if it's open down or the lowest if it's open up. Okay. So here's another way to actually think about it. It's a point where the graph does what? Come on. Where the graph does what? Changes direction. Why? Because it's either going down and then it starts to what? Go up, or it's either going up and then starts to what? Go down. Okay, so it's when it decides either I reach the minimum I could go or the what? Maximum I could hit. Okay, so that's what the vertex is. So whenever I ask you to find the vertex, this is just code for asking you to find either the highest point or the lowest point, depending on how the shape looks like. Okay, 1 second. Let me just get the layout up. Yep, there we go. All right, next. Okay, second. There we go. Next, maximum value. What does maximum mean? Lowest or highest? So this is the highest y value you could get to, or the highest height. It would say the highest height. Okay, so this only occurs, by the way, does this have a high or a low? No, no. How about this one? It has high. So a highest point only happens if it's open what? If it's open down. Good. So occurs or happens or shows only if the parabola opens down. Okay. So opens down. Okay. So I want you to go like this. Just sketch something that kind of opens down and put a line right here. It should really touch it. So let me really make it touch it. Come on. Yeah, that's kind of like this. Okay, this is the maximum value. It's the highest it could ever get. Okay, so it actually is the y value, and is the y value of, oh, it's the top or highest y value you could ever get. So it's the highest. It's the highest y value. Also, it also happens to be the y value of the vertex. The y value of the vertex. Now the x value, the y value of the vertex. Okay. Can I say almost the same thing about the minimum value? Yeah, but I have to just what? Change everything. So instead of down, it opens up like this. Look, like this. That would be a lowest value right there where my hand touches it, which means it's not the highest value, it's the what? Lowest value. Go ahead. So the opens up. So I want you to sketch a upward U, kind of like this, and then put a dashed line. Yes, there we go. It's like the ground. It is the lowest y value, and it also happens to be the y value of the vertex. Okay, so far they're basic features of any curve that looks like a parabola. Okay, okay, next one. No, no. Axis of what? Who can read this word? Symmetry. What does it mean to have something symmetric? Exactly. So, for example, is my body symmetric? You're absolutely right. You always have what? There's always what? Certain parts on the left side that are what? Not identical to the what? To the right side. But roughly speaking, is there a line that cuts me, that divides me into two identical halves? Where is it? Right where? Right, guys. Right exactly where? In the middle. So the axis of symmetry is always a what, by the way? It's never what? It's never horizontal because the okay, question. Listen up, everyone. What if the parabola was open, guys? What if the parabola was open this way? Where would the axis be? This way or this way? How would you cut this into two identical halves? Not this way. Which way? You gotta go this way, right? Same thing here. But if it's open this way, how do you cut it in two halves? Either this way or this way. So your axis of symmetry is always what? Is always what? A vertical line that cuts it perfectly into two identical halves. Right? Okay. So it's a vertical line passing through the what? It must pass through the vertex because the vertex is the perfect middle point of the entire curve. So it's a vertical. I want you to circle or highlight vertical passing through the vertex. Come on. By the way, just a word of caution here. Never bother saying the vertex point. Just say the what? Because the vertex itself is a what? It's a point. So whenever, by the way, whenever I ask you where is the vertex, you can't tell me, oh, it's at 5 or it's at 6. No, you have to give me how many values? You have to give me the x location and the y location. You have to give me two values for the point. Okay? All right. Its equation is in the following form. X equals some number. What is that number? No. It actually is the x value of the vertex. So go ahead, and I want you to highlight this some number and then say the x value of vertex. You see how the vertex is super important? It appears in the axis of symmetry. It appears in the minimum value. It appears in the maximum value. The vertex is the central point of the whole thing, as it should be. What does the word intercept mean, even in English? Cross or intersects or cuts or goes through. So the y-intercept is the what? Everyone, it's the what? Everyone, there are no multiple y-intercepts. There are only how many? One. A curve, not just a curve, sorry. A parabola cuts the y-axis only how many times? 1. It can never, okay, everyone. By the way, this is the y and this is the x. How many times did this curve cut the y-axis? Come on. Just once. Where? Right here. Is there any way that this curve could cut the y-axis again? Why not? Because there's no way it's going to what? Curve this way, right? Okay. Interesting. How many times could it cut the x-axis? Good, good. But as far as the y is concerned, only how many cut? Good. All right. So I want you to highlight the word 1. So it's the 1 point where the parabola crosses or passes through the y axis. Y, come on, y axis. There is only how many? It cannot cross twice or 3. It just can't cross more than once. So there is only one y. By the way, listen up. I will never write y intercept. We just write y what? I n t. Everyone, you see int, it means intercept. No, even when you do a therefore statement, never bother intercept. Just write int. I n t. Just like that. I n t. It cannot cross more than than 1. It cannot cross more than once. Because then it means it weirdly goes like this. Nope, that never happened. Okay. I'm sorry. How about the x-intercept? What's this? Intercept? It could cut what? Okay, everyone. Oh, thank you. Okay. I'm going to use Desmos for a bit. Here it is. Okay. Everyone. Y equals. How many times does this curve cut the x-axis? X. We don't care about the y. We know it's a 1. How can you see them? Yes. Apparently. By the way, Desmos is amazing. You can click on this and I tell you perfectly the number, like up to 3 or 4 decimal points. Look, you can just click. So apparently, this point is from the 0 left side, because it's a minus, 2.73. Yeah, it's between 2 and 4, and it's slightly less than 3. Click on the other one. It's positive, but it's what? Small, because it's very close to the 0. You only moved this way. You didn't even hit the 1 yet, or the 2. You hit 0.37. So how many cuts do we have here? Okay, everyone, check this one out. How many times? Come on. Eyes on the screen. How many times does it cut the x-axis now? Does it even touch the x-axis? Okay, so now we dealt with how many extremes? 2. It could either cut twice or it could cut no times. What's the case in between? It could cut twice. It could never cut. What's in between 2 and 0? It could cut once. Let me show you how it looks like if it could cut once. Oh, sorry. How many times does it cut? By the way, you might say, maybe it cuts twice. Maybe you just didn't zoom in to see that what? Maybe it dips below. Everyone, look. Oh, here's an easier way. Eyes on me, everyone. How many times does it cut here? That's once. You see, it did not go below. So you might say, Mr. Ramadan, zoom in more. I think it dips below. You can zoom in forever. This equation will never touch more than. Go ahead. Let's zoom in on our point here. Is it still cutting once? Is it dipping below? Is it slightly above, or is it perfectly on the line? Right, actually, here's the thing. I could add a little bit of a drag up here, and then it would never what? Touch the line. But is it touching the line here? How many times? So what are the cases? It could cut how many times? 2 or do you think it could cut 3 times? Could you ever make this guy? How many times does it cut here? So yeah. What would you have to make to this to make it cut 3 times? I would have to do what? I would have to what? Look. Right? But is this a parabola anymore? A parabola only looks this way, or it could never have another arm that goes what? Up and down like a wave, right? Nope. So the problem is, how many x-intercepts do you have here? Now, 1, 2, but it's not a what? It's not a quadratic anymore. It's not a parabola. Do we study anything more than a parabola in this course? Not in grade 11. You do a little bit of higher ones in grade 12, but that can never happen. So what's the maximum number of x cuts? 2, 3? No way, because then it has to dip down again. So that means it's 2, and that's it. So I will actually show you the one I'm going to post today. There you go, everyone. So I want you to copy this. Go ahead. Okay. So, everyone. So there can be how many cases only? 3 cases. The best case, I mean, there's nothing bad about not cutting, but the best case would be cutting how many times? Twice. Look at this. 2 touching points. By the way, maybe touching is not the best word because it actually doesn't touch. It actually literally goes through. So maybe we should change this to crossing. Yeah, cross. Touching means, look, everyone, touching means 1 cut and that's it. No. Everyone, let's change it. So it's a good thing I'm using this file. So change this touching. Maran, what did we say? Crossing. Yes. 2 crossing points. Well, so kind of like this, it crosses twice. Or this one where it's open down, but it still crosses twice. So 2 x ints or intercepts, which means cuts twice the x-axis. I should say the x-axis. Let me change it. The x-axis. Okay, so that's one case. 2 crossing points. Feel more than okay to label the crossing points on your diagram right here for this one. Say again. Okay, everyone. Do we see them touching the y now? But do we know they will eventually touch it? Yeah, if you extend it enough, look, this one's going to keep going down, right? This arm, it's going to touch for sure. How about this one? Is it also going to touch the y-axis? Yeah, but you're going to have to really what? keep going up and slightly open, open, until they what? Until they. By the way, there is always a y-intercept. Here's the weird thing. There is always a y-intercept, but there might not be a what? An x-intercept, because it might be fully above the x or fully below the x. We're going to get to that case. So you're absolutely right. Ether is correct. There is always got to be a touch. You just have to keep going until you physically see it. Oftentimes, if it's really far, I might not show it, and I might just show the two exercises, depending on the situation. Okay, depending on the situation. Okay, case number 2. Instead of crossing twice, just crossing once. Just crossing once only. But that's a very delicate case because you literally don't cross. You just what? You touch. You graze. Okay, so that's the second case. Case number 2. 1. And you know what? Maram, do you think touching is a good word now? Yes, it's not. To me, crossing means you literally crossed a line. It didn't cross. It only touched. So I think touching is a good point, is a good word. 1 x-intercept, which means cuts once the x-axis. Cuts once the x-axis. On the x-axis. And I'm going to label my single point of touching right here. Right here. And what's the other case that is the most other extreme? Absolutely doesn't touch, which means you are either fully above the line, or fully what? Fully above or fully below. That's it. There is no other way to make it look like if it's not touching at all. So no touching point, which means no x-intercept or intercepts, which means never cuts or never touches even the x-axis. The x-axis. Which means there's nothing to label here because it doesn't exist. So I'm just going to remove those two. There we go. Those are the only 3 cases. There's absolutely nothing else. Case 1, case 2, case 3. Yeah, yeah. One second. 1 second. Zoom out. So 2 points. Oh, sorry. There is one. Yes, my bad. Oh, sorry. Yes. So the 2 points or one single point. Yeah. By the way, does it say one single point in your note? Yeah, yeah. It should be one single point. You can't say one single point. So I apologize. Where the parabola crosses or goes through the x-axis. Yes. Okay. Let me just go down. So if you miss, come on. Okay. The last thing. Okay. I do not control how they name things in math. Sometimes they have multiple names for the exact same thing. So everyone, there's something called zeros. Guess what? Zeros are the same as the what? As the same as the what? As the x-intercept. So the question is now, why do they call them zeros? Well, to answer that, let me show you this. Everyone, just give me 30 seconds. I'll go back to Desmos. Everyone, look at those 2 points. Do they have the same x value or different ones? Everyone, come on. Do they have the same x value or different ones? Different ones. Do they have the same y value? Look at the y value. What's the y value for both points? 0. That's why they call them what? They call those points. What do they call them? What's the last thing on the chart? Zeros. So again, I don't care if you call them zeros or x-intercepts, because that's what really happened. If you call them x-intercepts, that means what? You're focusing on what happens as it goes through the x-axis. If you call them zeros, that means you're telling me, oh, they just have a y value of 0. Guess what? One definitely means the other. If you're cutting the x-axis, if you are intercepting, yes, intercepting the x-axis, that means the y value is what? And if you say, if the y value is 0, that means you are intercepting the x-axis. So it's literally saying the same thing twice. It's like saying, how tall am I? I could say 5'9", which is in what? In what units? 5'9", feet and inches. Or I could say about 175 centimeters. It's the same number. It's the same information, just presented in two different ways. Okay? So zeros. There we go. This is the full one. Yes. So zeros is the same as x-intercepts. So again, how many zeros could you have? 2 zeros or 1 0 or no zeros. Basically, how many times do you cut the x-axis? Yes, they are called zeros because the height of the function or the parabola is equal to 0 at those points. Another way to say it, because y value, I hope you can read my handwriting, because y value at x-intercepts is always 0. Okay? Those are all the features of any quadratic. So, okay, everyone, let's recap in 1 minute. Every quadratic has a what? What was the first thing on the chart? Come on. Every quadratic has a what? No. The first thing on the chart has a what? Has a vertex. All quadratics either are open what? Are open up, which means the vertex is here, or open what? So with the vertex here. Okay. Also, every quadratic either has a what? A minimum value or a maximum value. Okay, what's the third thing on the chart? All of them are perfectly symmetric. Everyone, eyes on me. So all of them can be perfectly cut into what kind of halves? Two what? Two, not just any two halves. Two different or identical. Two identical halves, whether it's open up or open down. What's the fifth? What's the fifth feature? All of them have how many y-intercepts? 1. You just have to keep growing it until you find it. Okay? Or keep zooming in and moving the thing on Desmos. What's the sixth thing? All of them have what? Okay. Some of them have how many intercepts? Come on, everyone, eyes on me. Some of them have how many intercepts? Sorry, x-intercepts. Some of them have none or 0. Which also means some of them have how many zeros? 2 zeros or 0 zeros or just no zeros. Every quadratic must have those things. Which is why, go ahead, flip the page. We will actually look at some of them and you tell me what each feature is. The graph is yours or there for you. You just have to look and decide. So let me go to the blank one. There we go. Come on. Okay. I hope you can see the numbers on your grid on your paper. Now, can someone tell me how many times does this cut the x-axis? 2. Can you tell me at what x values? Come on. So, yes. So everyone, let's zoom in. Everyone, let's zoom in case you can't see clearly. What's this value? -3. What's this value? No. Okay, remember, if it's -1, you're on the left side. You are on the what side? You're on the right side. You're always positive. Okay, so I actually, you know what? Let's label things on here. So I want you to label. I mean, you can always add things to the diagram. So go ahead and label. Oops, sorry. I want you to label here. Oh, I need to change the layout. Sorry. Oh, my bad. Second. Microsoft Word is very sensitive to layout issues. I think now I'm good. All right. So I want you to draw, label, or point to this point. Oh, sorry. Now we're good. Oh, yes, yes. Sorry, I was highlighting the wrong part. Okay. Yes, we're good. It doesn't shift it. All right. So go ahead, everyone. Highlight this one. So highlight or point or label it. Also, you point to this one. What are those? Are those y-intercepts or x-intercepts? By the way, could you ever have two y-intercepts? No, you can only have what? Just one. No more, no less. Which means I want you to call this one x-intercept number 1, which means this is what? X-intercept number 2. Good job. What would you call this point? Right here. What do you call this point? The vertex is either the lowest point or the what? Or the highest point. So let's call this vertex. Do not call it vertex point. It is a point. Vertex. Can anyone see the y-intercept? Yeah, it might. Yeah, what is it? +3 or -3? Apparently, it cuts below the axis. -1, -2, -3. So I want you to point to it. Point to it, and say y intercept. Y intercept. Sorry, let's go here. Everyone, come on. Any other features I could highlight? We pinned the two x-intercepts. We pinned the vertex. We pinned the y-intercept. Sure, Ether. You know what? Here's a hint for everyone. If I can see the vertex, what goes through the vertex? A vertical line. What? Axis of symmetry. What kind of a line is it? A vertical straight line. Everyone, rulers, because I want you to go through the vertex perfectly as a vertical line. Gonna give one for each table because I don't have enough. Go, go, go. Come on. Vertical line. Perfectly through this. Perfectly through this. Just trace this line, the -1. Come on. Use rulers, please. All right. I'll try my best to sketch it. Actually, I can insert a line. There we go. Shape, line. Goes through here. I believe this is the best I could do here. Let's make it a thick line. Yes, there we go. So what do you write next to this? Okay, can you flip the page, look at the chart, look at what I call the axis of symmetry. It's a long phrase. What do you call it? What do I call it? A capital, O small, S capital. Axis of symmetry. Axis of symmetry. So you just go here and you write A, O, S. That's it. Any other features I can pin on this? Say again? Yeah, I mean, yes. By the way, could I have said x-intercept equals -3? Yeah. But you know what? Let's actually do that where? In the chart. Everyone, let's go to the chart now. Oh, yeah. The what, sorry? Oh, I did. I penned them. Which one are you talking about? You mean this one? Oh, we did. It's those two. But it touches twice. Remember? This one touches twice. Okay, let me explain something. Everyone, Maram is saying, listen up, guys. Maram is saying, can you also show the single point it touches the x-axis at? Here's the thing. Can a parabola both touch twice and once at the same time? What do you think? What do people think? Come on. Can the curve touch the x-axis both twice and once at the same time? No, it either touches twice, or if I lift it up, I could just make it touch how many times? Or if I lift it really up, or if I take it and flip it here, it would never touch because it would look like this, right? So you don't have multiple cases. Each parabola could have one of how many? Three cases. Either touches how many times? Twice. Which case is this one? The touching twice. That's it. Make sense? That's it. All right, everyone, let's actually write now those values in the chart. Okay. What's the first thing I'm asking you for? The what? Or they're called zeros. How many x-intercepts do we have? Come on. 2. Where is the first one located? -3. Where is the second one located? So all you have to write is this. Everyone, this is important. Let me show you the wrong ways of putting this on. You cannot do this. Everyone, eyes up here. You cannot do this. You know why I can't do this? Because this might look like a 1 point, and even though some people, when they write it this way, they go like this. I'm sorry, that's point -3 and 1, which has nothing to do with anything. You actually have to write it this way. It's not, again, this is the official way, and it's not really that hard. You have to write x equals -3, comma, x equals what? You have to tell me the numbers, but you have to write x equals before. You have to write x equals before. You cannot just write -3. You cannot just write 1. You have got to write each one in its own statement. Okay, can someone tell me how low does it cut the y-axis? How low does it cut the y-axis? We pinned it. Angela? No, no, no. You're giving me, I think you're giving me the vertex. Yeah, look, everyone. Angela's giving me this. Angela's giving me this point. I'm asking you for what? How low does it cut? Okay, Zainab, wait. You have to say no. Y equals -3. Yeah, that's it. You have to tell me y equals that height. Again, it's the way that it should be written. Second? No, no. The 0 is the x coordinate of it. I don't care for that. I just need the what? The other number. Yes. So, everyone, we're going to go to the chart. Come on. Y equals, okay, vertex as a point. Which means I need this, and I need this, and I need that. Okay, Angela, you did this before? Oh, well, you know what? Let's look. All just like English, x then y. Everyone, x, y. It's never y, x. So, yeah. Let me just zoom in. Everyone, what's the location of this point? How much do you have this way first? How low did you go to? So what do you say? minus 1, comma, minus 4. That's it. Minus 1, minus 4. Oops, sorry. Question. That parabola. Where's the root? What? Okay, wait, before you say, Dylan, I said you can't do what? This is important because this will cost you communication. Huh? That is the vertex. Okay, whoa, no, wait. The only one that you have to give as a full point, is the vertex information. The only one that you need to give as a point is the vertex. Everything else must look something like this. Okay, here's my question to you this way. Does this curve have a top or a bottom? Look at it. Look at the curve. Does it have a high one or a low one? It has a what? Which one is low? Max or min? Min. Minimum means what? The lowest thing. So that means we have to, yes. You have to say min. You have to say min. And what's the lowest thing it gets to? By the way, that's only the y coordinate of the vertex. What's the y coordinate of the vertex? Yes, min. And you say y equals negative 4. Again, you're looking at the y-intercept. I am asking for the y value of the vertex, which is minus 4. Okay, no, wait, Ether, before I answer your question, look. Where is the lowest level? Right here, right? Minus 4. Okay, Maram, and other people as well. There's a difference between the what? The y-intercept and the y value of the vertex. The y-intercept is when it cuts the y-axis. The y of the vertex is just how low it gets. Either. So, yes, it's always not as a point. It's literally just x equals, and y equals. The only thing that you give as a point is the what? Vertex, 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 and that's it. Okay. Next one. Dalal, what's the next one? Come on. Axis of symmetry. Where is it? Can someone tell me where it cuts? Yeah. Where does it cut? That's it. You just say what? X equals negative 1. Done. That's it. Those are all the what? The information we need. I just want to prove to you that this actually is the what? Is the equation for the what? Come on. Axis of symmetry. Check this out, everyone. I'm going to go to Desmos. Everyone, what are the numbers for the vertex here? 5 and negative 5. So what's the value for x? Everyone, just eyes on the screen. 10 seconds. Look what's going to happen when I tell Desmos to sketch x equals 5. Ready? 1. So it is true. X equals 5 is the equation for the what? For the axis of for the axis of perfect symmetry. That's why it's an x. Okay, here's a question. Listen up. What if I told Desmos to sketch y equal 5? That's not going to be an axis of symmetry. Look how it's going to look like. Is that blue line now an axis of symmetry? Is that dividing it into two halves? No, that's just cutting it up there. That's why it has to be what? X equals, not y equals. There we go. I changed it a little bit, but it's still the same thing. Okay? All right, let's do the next one. Should we treat it the same way? What's the most major difference between them? Instead of open up, this one opens what? But is it still more or less the same idea? 100%. Okay. Yes. So let's put numbers or pinpoints on it. How many times does it cut the x-axis? Twice. Once here and once there. So let's label. Okay, I'm going to zoom in. All right, I'm going to use purple this time. So one here. Oh my God, not again. Sorry. Yeah. Oh, it is good. All right. Okay. That's one. That's two. Those are what? Are those y or x intercepts? Of course, there's more than one. They have to be x intercept. So go ahead and write x intercept number one and x intercept number two. What else can we pin? Always. Come on. But you can do them in any order you want. The y what? The y intercept. Where is it? Yeah, sadly it's a decimal, but don't worry. On your tests and quizzes and stuff, you will always have easy number to read. So I'm gonna pin it inside here. I'm gonna say y intercept. What else can I pin? The what? The vertex, which is definitely right here. Right through it. You have rulers, might as well cut it through. Go. So I'll write vertex here, so it doesn't go through the point or the line. And then I'm gonna go draw. No, insert, I guess. Insert shape. Let's see. Yeah, I think that. Yep, perfectly straight up. And I need to just make it more thickness. There we go. AOS. Yes, thank you. It's again AOS. A small o. Please make it a small o. Capital S. Thank you. Anything else I could pen? Right? I could, but it's already included in the vertex information. Right? I Yeah, but it's already included where? In the vertex information. So just by showing me where the vertex is, you are kind of showing me where the maximum or the minimum is. Did we do any more in the first one? That's it. All right. Then let's what? Let's put the numbers in. Okay. First thing I'm asking about. Same way. X intercept. So x equals what? Could you say x equals 7, comma, x equals -1? Yes, you can give them to me any order you want. However, it's always easy to start on the left and go to the one on the right. But you're not going to lose marks if you just put them in any order you want. So, um, all right. So, let's zoom out. So, x equals -1, comma, or and, but comma is more common. X equals what? 7. Okay. Where does it really cut the the y-axis? Okay, let me zoom in. Is it right in the middle? Okay. How much is this number? Okay. How many squares do you have? Everyone, I know this will not be a test or a quiz question. Don't worry. It just gonna take time to what? To kind of like, work out the size of each square. The full thing is how much? 1. But it's divided into how many squares? 4, right? So that means, let me just put it here. So that means, tell me if you agree with this. Yeah, yeah, yeah. Like 25% each, right? So everyone, look. Here's 1 cut, 2 cuts, 3 cuts. So here's what? Come on, guys. Keep it down, please. Thank you. This one is what? Or 50 or whatever. Right? Where does it cut exactly? I'll give you an easy one. What do you call a value that exists right in between two other values? No, but I'm asking you, what do you call a value that goes right in between two other values? I'll give you a hint. How many people are taking 2 courses right now? 2 courses, just 2. What do you always calculate at the end of the term? What do you always calculate when you get your marks? What do you always calculate? You need what? You need your average. Is this exactly in between? So is it exactly the average of those two? Yes. Do you see what I mean? It's like you got 75% on a course and you got 100% on another course. What do? You add them up and you divide by 2. So let's do that here. 0.75 plus what? Divided by, okay, that's 1 point what? And you see, you thought it was 85. There is no need to guess when you know the average. Just add and divide by 2. So 0.8 what? That's it. So we go here. But how do we write it? Look how we wrote it in the first one. Y equals 0.875. But does it cut at 1? I could have made it, but I lowered it a little bit. Point. Again. Okay, everyone, listen up. The worst that I'm going to give you on a quiz or a test is something that's easy to read, like between 1 and 2, which is what? What's right between 1 and 2? 1.5. That's it. You're not going to have to do this average thing. You're just going, between 3 and 4, 3.5. That's it. Done. I'm not going to give you any more. Okay. All right. What's the third thing that we need? The vertex as a what? As a full point. It's the only one that's a full point. All right. Let's zoom in and look very carefully to where the vertex is. All right. That's right. 3. Done. Which one goes first? Y or X? Just like English. X, Y. So, comma, 3, comma 2 in a bracket. So you just write. Yep. Oh, you always start with the X. Yes. So 3. Sorry, that's a bad 3. 3, comma 2, and you have to put the what? Thank you. Because it's a point. All points have brackets. You signing up? Okay. Does this curve, the one you have, listen up, does it have a max or a min now? Because it's not a bottom, it's a what? It's a top. So you can say max The max, Jordan, the max is always y equals. But it's the y equal to what? You just take the y of the vertex, which is what? It's my point is when you know the vertex, you know the next two things immediately. One of them is the y, one of them is the x. The x of symmetry is the x. So you just go like this. Done. Literally. You already know it. You just have to write it in its own statement. And finally, x equals what? 3. So x equals 3. You see, once you know the meaning of everything in these weird words that you're probably seeing for the first time, it's really easy to understand where they are on the graph.